Hello and welcome to Math 200 Online Statistics at Cañada College. My name is Lapuz. In this video, we will take a look at a homework problem from section 11.2. It says here that the table lists the number of games played in a yearly best-of-7 baseball championship series, along with the expected proportions for the number of games played with teams of equal abilities. Use a 0.05 significance level to test the claim that the actual number of games fit the distribution indicated by the expected proportions. So imagine a game being played as a best of 7, and it's possible that a team can finish in 4 games and win all 4 games, or they can lose 1 game and win 4, so they played 5 games, etc. So according to the records, 20 times one team swept the other team by winning all 4 games. 22 times one team won by winning 4 games and losing 1 game, etc. And so they gave this expected proportion values here. So let's first fill out the null and alternative hypothesis, and the claim is that the actual number fit the distribution of expected values. So that seems like it's going to be the null hypothesis where all of the distributions would agree with the expected proportions. So the observations would agree with the expected proportions. Now the logical opposite of that, you just need one of them to be different. And when one of them is different from the others, then from the expected proportion, then the null hypothesis would then not be true. So this is our null and alternative hypotheses. Next, they want us to calculate the test statistic, and for that we are going to copy this and paste it onto our Google Sheets. So we'll overwrite the category. The second is the observed, so it's called actual now. Let's just call it O for observed. And then we have the expected proportions here. And then the expected value, we need to fill this in so we can properly use this formula. And this formula will help us find our test statistic. Okay. First of all, we need to figure out how many data sets that we have. And for that we will say equals, and then we will add up all these numbers. And it looks like there's 101 games that were, or series that were played. The number of categories, 1, 2, 3, 4, there's 4 of them. And the degrees of freedom is equal to this number that we just got minus 1, so that's just 3. Okay, to find our test statistic we need to do this computation, but first we need to find our expected frequencies. So we need to figure this out. So we know that there's 101 total numbers that were counted. So our expectation here would be equal to this proportion out of, or of, 101. So it's going to be for a team to sweep the other team, we would expect about 12 and a half, 13 times that would happen. If we click and drag, we'll see that these are the rest of the expected proportions, or expected values, sorry. Okay, now we will use this formula. We'll say equals, open parentheses, the observed frequency minus the expected frequency, close the parentheses, quantity squared, divided by the expected frequency. And we will do this formula for each of these. So I just click and drag to fill in the rest of that table. And then now I want to add up all these numbers. And by adding up all those numbers, I will get the test statistic. So let's put it here, equals the sum of all these numbers, and our test statistic is going to be 7.673. So let's try that. 7.673. Okay, now that we have that value figured out, we want to find our p-value. This is a chi-square test on the right side, and so fortunately there's a nice formula for that in Excel or in Google Sheets. So we'll type in equals and CHISQ for chi-square. We're going to do a distribution, so that's DIST, and then it's going to be a right tail, so we're just going to do the RT for the right. And it takes two arguments. The first one is the test statistic that we found, and then comma, the second one is the degrees of freedom, which in this case is 3, and then that's it. So our our p-value is going to be 0.05326. So if we want to round this off to 4 decimal places, 6 is bigger than 5, so we're going to take the 2 and add 1 to it, and we have our p-value. So our p-value is ever so slightly bigger than our significance level, but the fact that it's bigger than our significance level means we're going to fail to reject the null hypothesis. So we're going to, one of these two choices, fail to reject the null hypothesis. And for that, let's look at the claim again. Actual numbers fit the expected proportion. So the claim fell onto the null hypothesis, and we just rejected the null hypothesis, so we rejected the claim. Or I'm sorry, we failed to reject the null hypothesis, so we are going to be unable to reject the claim. So there is insufficient evidence to warrant the rejection of the claim that the actual games fit the distribution. Let's check that. Okay. I hope that helps.